Hey Harry, how's your brain feeling today? Ready for some logic?
As ready as it can be. What are we learning today? Please say it's not more math.
Haha, not quite math, but close. Today we're talking about comparison and logical operators.
Oof, that sounds like robot language.
It does. But it's actually how we teach the computer to think like us. Sort of.
All right, go on.
Let's start simple. In real life, we compare things all the time. We say things like, I'm taller than you, or that coffee is cheaper.
Yeah, or like, this cat is fluffier than that one. Very important comparisons.
Exactly. In JavaScript, we use special symbols to make these comparisons. They're called comparison operators.
And what do?
They help us ask questions in code. For example, is the number 5 greater than the number 3? Is 10 equal to 10?
And the computer says, yes or no.
Yes. The computer replies with true or false. That's how it makes decisions.
So basically, it's like asking the computer, hey, is this bigger than that?
Exactly. Let me break it down. When we want to check if something is greater, we use the greater than symbol. It looks like an open arrow pointing to the right. So if we compare 5 and 3, we say, is 5 greater than 3? The answer is true.
Okay, got it. What's next?
Then we have less than, which is the opposite. It's an arrow pointing to the left. Like asking, is 2 less than 10?
Which is true, obviously.
Then we go a step further. We can ask, is 5 greater than or equal to 5? The answer is also true. Now here comes something tricky, checking if things are equal.
I already don't trust this part.
We have 2 ways to do that. One uses 2 equal signs side by side. That checks if values look the same, even if they are not the same type.
Wait, type? What do you mean?
Let's say you compare the number 5 with the word 5 in side quotation marks.
So like comparing a real apple to the word apple written on a box?
Exactly. If we use 2 equal signs, the computer says true because it only checks value, not the type.
Wow, that feels a bit lazy.
That's why we have a stricter option, 3 equal signs. That one checks if the value and the type are the same.
So now it's like saying, I want a red apple, not just anything with an apple sticker.
Boom! That's strict equality.
This is wild. Wait, what about not equal? Like when I say, I do not like broccoli.
Great one. We use an exclamation mark followed by an equal sign. That means not equal. And if we want strict not equal, we add 2 equal signs. So, exclamation equal equal.
So the more equal signs, the stricter the check?
You got it. The more careful you want to be, the more precise the symbol.
I feel like I'm learning a secret handshake.
Welcome to the club. Now let's talk about logic, the ands, ORs, and nots.
Sounds deep.
Let's say you want to go to the park, but only if it's sunny and you have free time.
Okay, so both have to be true.
Yes, we write condition 1 and condition 2. In code, we use 2 ampersands. If even one of those things is false, like it's raining, then the whole thing is false.
Fair enough. What about or?
Or is more flexible. You say, I'll watch a movie if I'm tired or bored. In code, we use 2 vertical lines. That means or.
So if either is true, I still watch the movie.
Exactly.
Like if I say, I do not like Mondays.
Exactly. And that little exclamation mark flips the meaning from yes. To note that SOD symbols are tiny, but they really pack power. They sure do. And now, let's see how they work in real situations. Let's pretend you're building a little app. It needs to show a message based on someone's age.
All right. Let's say the person is 20 years old.
Perfect. Now you want the app to show you are an adult. If the age is greater than or equal to 18.
So I check, is age greater than or equal to 18?
Exactly. That's using the greater than or equal to operator. If the person is 20, then 20 is greater than or equal to 18, and the answer is true.
What if the person is 16?
Then the condition is false. So the app wouldn't show the message.
Cool. What if I want to show a message only to kids under 13?
Then you check, is age less than 13? If it's true, show the message. If not, do nothing. These kinds of checks are called conditions. They let programs behave differently based on data.
So it's like the app is asking, is this true? And reacting to the answer.
Exactly. Now, let's add logic to the mix. Imagine a concert. You want to allow someone inside only if they are older than 18 and they have a valid ticket.
So both must be true, age and ticket?
Right. We connect them with two ampersands, the AND operator.
And if one is false, like no ticket, the answer is false?
Correct. Think of a lockbox that needs two keys. If either key is missing, the box stays closed.
Okay. What if the rule is, you can enter if you're a student or over 65?
Now that's OR. You write two vertical bars. Only one of those needs to be true.
So it's more relaxed. Either being a student or a senior is enough.
Exactly. OR is used when you want to include more people. Let's try a fun one. Imagine a robot dog that only plays if you're happy and it's Saturday.
So if I'm sad or it's Tuesday, no games?
Right. But if you change it to OR, then the dog plays if you're happy or it's Saturday. Much friendlier.
Haha, I want that version.
Now let's talk about not. It means the opposite.
Like not hungry means full?
Exactly. We write not with an exclamation mark. It flips true to false and false to true. If is weekend is true, then not is weekend is false.
So I could say, if not raining, go outside?
Yes, that's a common use. You can also combine logic and comparison. For example, if age is over 16 and agreement is accepted, give access.
So both the number and the condition must be true.
Exactly. It's like checking someone's age, and if they clicked I agree.
And I guess I could also use OR. Like, show a message if user is an admin or a guest.
Perfect. That's how you control access, display info, and guide behavior in apps.
Okay, now it's clicking. These symbols are like switches in a giant control panel.
Yes. And now imagine you can control that panel with your own rules.
One more. If the user has points more than 50 and is online, unlock a bonus?
Exactly. That's the real stuff.
I'm starting to feel like a code wizard now.
Well, every wizard needs practice. Ready for a little logic challenge?
Bring it on.
All right, here's a challenge. Imagine you're checking if a user can access a special level in a game. The rule is they must be over 15 years old and have collected at least 5 stars.
Okay, so both need to be true, age and stars.
Exactly. Now try saying that as a condition.
Is age greater than 15 and stars greater than or equal to 5?
Boom. That's perfect logic.
Nice. What's next?
Now change the rule. A user can access a level if they are over 15 or have 5 stars.
So now either one is enough. I'd write, age greater than 15 or stars at least 5.
Exactly. You're getting the hang of it.
Wait, what if someone enters nothing? Like no age, no stars?
Great question. If both conditions are false, the whole rule is false. Access denied. That's why we always check for defaults or missing values in real apps.
Got it. Makes sense.
Now one more, use not. Say the user has a setting called is banned. If it's true, they can't log in.
So I check, not is banned. That means if they're not banned, allow login.
Exactly. That's a common use of not.
Wow, these tiny symbols really do all the decision making.
Yes, and combining them lets you describe almost any rule.
So I could say, if score is over 100 and not banned, give prize.
You're coding like a pro now.
Haha, thanks. But I feel like I'll forget all this unless I use it soon.
That's a smart point. Learning code is like learning a new language. You have to practice. Write small conditions. Try mixing and or not. Change numbers. Break things and fix them.
I will. Maybe I'll make a mini app where I ask questions and the app answers yes or no.
Great idea. That's the perfect way to practice these operators.
And maybe I'll make a robot that brings coffee if I'm tired or cold.
Haha. Don't forget to feed him JSON too.
Right. Coffee and clean data.
One last tip. Always test your conditions. Use print statements or logs to check what's true or false.
I'll remember that. Even when it feels easy, I'll double-check.
Good habit. Errors in logic are sneaky. They hide in plain sight.
Like writing or when I meant and oof.
We've all been there. Before we finish, let's review what are the main comparison operators.
Let me say them out loud so I don't forget. Greater than, that's the greater than symbol. Less than, it's the one pointing the other way. Equal, that's two equal signs side by side. Not equal, an exclamation mark and one equal sign. Strict equal, three equal signs. Strict not equal, exclamation and two equals.
Perfect. And what about logical operators?
And that's two ampersands, and both sides must be true. Or two vertical bars, one true is enough. Not one exclamation mark, it flips the answer.
You nailed it.
Thanks, James. This lesson was kind of fun. Don't tell my past self I said that.
It'll be our secret. And remember, logic gets easier the more you use it. Don't just watch and listen. Practice. Type the conditions yourself. Try silly ones. Try useful ones. Make your brain do the work.
You mean, actually touch the keyboard?
Haha, yes. Logic isn't learned by watching. It's learned by building.
All right then. Time to click-clack my way into becoming a real coder.
That's the spirit. And if you ever feel stuck, just remember one thing.
Let me guess, feed your brain, not just your robot.
Exactly. And feed it daily with a little practice.
See you next time, James. I'll bring questions, coffee, and a bug or two. Thank you again.